Well, hello. I think it was from this very same beach that 1 year ago I was talking about AI and my early impressions. And yeah, I don't know if you will enjoy the sound of the waves, but yeah, they're considered noise. So I will just use the noise suppression. There we go. So hopefully now you will just hear me. I don't know if that's an improvement or not, but I've been thinking a lot about some things. One of my early thoughts about AI had to do with the excitement when I noticed that they figured out language, right? And I explained in a video how, for many years, or since ever, they couldn't figure out how language worked because the focus was mostly in the language, in the sequence of words. And what I explained is language is just a linearization of a mind, right? So it really just a limitation. So if instead of focusing on that limitation, on the linearization, you should focus on the mind. How do we represent the mind? And the mind, as I explained, is an interconnection of concepts, and that is constantly evolving, changing, But the next question is, okay, if they figured out the mind, did they figure out intelligence? And I don't think they are the same thing. I don't think that a mind and intelligence are the same thing. The question would be, can you have a mind without intelligence? I would say, yes, you can. And LLMs are a good example of that. I would say that they're artificial minds, but they don't have artificial intelligence. Because intelligence is how you use the mind. Right? The intelligence is how you navigate that network of concepts. And language is how, in that navigation, you choose what you say. And that's the key word, choose. Choose. Choice requires intelligence, and that's where intelligence manifests. LLMs are not intelligent. They can only navigate the mind in a predetermined way, in a trained way. Everything that seems random or seems stochastic, it's not intelligence, it's artificial, it's imposed, or it's based on the limitations of the system, not on the strengths of the system. And we can talk a little more about that in some other time. But just I wanted to create that difference, right? To explain better that difference between a mind and intelligence, right? And consciousness as well. Consciousness is the self-reflection of intelligence. But if you don't have intelligence, you cannot have consciousness. So something can speak, something can create phrases, but not having any intelligence behind that. And I think I covered that enough in many different videos. But today I wanted to talk a little about what are we losing because of AI and the apparent ability to solve problems or to reason. And I wanted to talk a little about language again. And one particular kind of language, that is computer language, computer programming languages. And why are those important? Why those were a huge step forward for humanity, and that now we are taking back. So we're losing that ability. So to start with, we need to talk about the the limitations of language. Like we were explaining, language is just a linearization. What do I mean by linearization? Well, in your mind, you have all these concepts interconnected. But how do you communicate those to another mind? You need to use the vibrations of our vocal cords, and the cavities in our head and our lungs and everything, the position of the tongue and everything to produce sounds. And those sounds are reinterpreted by somebody else or the vibrations, inside of the ear. And then they go to their brain and, somehow they reach their mind, and what we say changes their mind, and what they say back changes our mind. So that's how we interact. And one video I explained that, well, that's the part of the problem with LLMs, is that they don't change their mind, right? We're not growing together through communication. It's a one-way communication that is cleverly reflected back, but without anything on the other side. So but that linearization is problematic, because some people are very good at saying things, at explaining their mind, explaining concepts, and some people are not. And also there's many ways that you can say something. If you think about it, you can say the brown dog, the dog is brown, the canine has the color of the, I don't know, whatever, right? So you get the idea. There's many ways that you can say basically the same thing using different words, different phrases, different linearization. Now, that leads to a big issue, that if you believe in the Bible and if you're, believe in God and in the creation and everything, that limitation of language was imposed. When people decided that they didn't need God, so they started to build this tower that will prevent God from killing them again, even though God had promised that he wouldn't. God decided to, discourage humanity by creating different languages. And that's what we call the Tower of Babel, event, where everybody started talking a different language and they couldn't communicate to each other, and that forced them to cease the work. So what God introduced is the limitations in language and what we will call ambiguity. And we see that ambiguity in everything that we say. So sometimes we try to say something and the other person understands something different. Even if we're using the same language, there's so many other things around that makes it very difficult for communication to be, I wouldn't say perfect, but noiseless enough that you would produce the exact changes that you intend in the interlocutor's mind, and vice versa, right? So we all have that. So we call them misunderstandings, and those happen all the time because of the ambiguity of the language. And different types of languages have different types of ambiguity. So, but we're reaching to a point in which we kind of develop a new language, the language of mathematics, that is limited in its scope of how can we change each other's mind, but is way less ambiguous. So it's not general purpose, is very specific, but we prove that we can remove the ambiguity when somebody says A plus B equals C. Those symbols and those letters can be understood by anybody else, right? We agree at a certain level that we can all communicate without any ambiguity. The next big thing was, well, when we created computers, and computers are basically mathematical machines, and a very basic type of mathematics that is Boolean mathematics. And already I recorded a whole video explaining about that. But basically you have zeros and ones and a few operators and or, and so on, that you could very cleverly put together to give instructions to a machine to do certain things, right? So that's how computers started. And originally everything was pretty much hardwired, so the computer would do just one thing, and you would just have a set of very basic instructions that for that machine to do something. But especially with transistors and integrated circuits and things like that, it became easier and easier to make these computers more flexible. Meaning that you can program them. You can give them sets of instructions and the computer will understand those instructions and do it, exactly what you say. But originally, well, not originally, we're still doing that. Those instructions had to be in zeros and ones, right? But it's so departed from what we feel natural. Nobody talks in zeros and one or on ons and offs or trues and false. It's very, very difficult. No human can speak natively that language. That we started creating different layers to make it easier for humans to communicate to computers. Now, the first thing that humans had to understand is that computers are very, very stupid. They will follow whatever instruction you give to them. They have no way to push back, to understand differently. If you say, do this, they will do that. There's no way they will do anything different than what you're telling them to do. So we need to communicate in a language that doesn't have any ambiguity. Computers don't understand ambiguity. And the idea of the high-level computer languages was for humans to have that ability. So how can we, basically using a combination of English and mathematics, and by mathematics I mean some symbols that were borrowed from mathematics, we can give instructions to these very dumb machines that will, just interpret what we're telling them. So obviously in the middle there's a lot of transformations that turn everything that we're saying into ones and zeros and fed into the computer so the computer can do what we're asking it to do. But that's very important. So finally, humans were able to create something that looks like a language. Again, kind of limited. It's not very useful to communicate with another humans, but at least it's a non-ambiguous way to communicate with something, right? To give instructions to something. Writing computer code, basically writing in those languages, is not hard. It's not hard at all. I would say it's even easier than learning a foreign language. I would say it's way easier. You just have a few keywords that are almost always in English, plain English that anybody can understand, and then you have some mathematical symbols. So let me put an example. You can say if A greater than 3, then A equal A plus 1, right? So what you're saying, well, if whatever value has A is greater than 3, then increase that number by 1. So take that number, add 1, and put it in the same place, in the same name, in the same variable, A. Is it difficult to understand? It is not. You just need to understand that, well, we're using if, then, which are borrowed from English. We're using greater than, that is borrowed from mathematics, equal, plus, also borrowed from mathematics. And basically, that is a sentence that could be understood in pretty much any language. So that was a huge step forward in our reasoning, in our learning capabilities, because I think it's the first time that we had, except mathematics, we had a way to communicate without ambiguity. We designed languages without ambiguity. And there were other efforts that were not related to computers, namely Esperanto, that this language that they tried to create that was kind of a mixture of many languages and was many languages, mostly European languages, right? But he tried to kind of merge everything into create a universal language that initially would replace French, that was the international language, and now basically English is that international language. But English is awful in its ambiguity, not only in pronunciation, but in the meaning of words. So Esperanto was a failure. Obviously, because we're not using it, nobody's using it pretty much. But we have, computer languages. And that's why if you have a friend who is a programmer, you probably notice that they're not very patient with ambiguity. Because most of their time, at least their working time, they're reducing ambiguity. They're trying to say, how do I say this in a way that it can only be understood in the way I'm intended to? And, how do you talk to a computer? That's why also people who are not programmers, they get very frustrated when they try to start programming, because the computer wouldn't do what they intend to do. And they feel like the computer is against them, right? Why is this stupid? Well, it's not stupid. It is stupid, but it's not stupid in that way. You're not giving unambiguous instructions. You're telling it to do something that is not what you intend to do. So you have to figure it out. You have to debug the problem. We in computer, we talk about debugging the code. Funnily enough, we never talk about debugging our communication, in English, but it would be the same idea. How do I get the intended results? Right? So you could still say, well, but this is still, too different from English, even though computer languages uses English. The idea was to create something that anybody could use. But then we got to what I would call the epitome. I don't know if that's a word in English. Well, of unambiguous language. And that is SQL. SQL. It's pronounced SQL. So SQL is a particular language that it's basically what is running everything around us. It's how do we interface, how do we interact with databases. So how do we write data into databases? How do we extract data into databases? And well, we've been storing data for many, many years, but always requires some kind of low-level language to retrieve that data, until we got to relational databases. And in relational databases, now you can connect different tables of data inside of the database, and you can join them and you can extract data from that. So this language was created that is called structured query language, and it's structured because that structure mimics the structure of how the data is stored in the database. And you cannot use unstructured. There's other, more modern ones are called NoSQL, no structure query languages, but that's completely different. But let's stay with SQL. So structure query language is how you query the databases, and this is pretty much English. The idea was that this would really allow almost anybody in the world who could speak English to query, retrieve data from the database. And the basic format is you start saying select, if you're going to retrieve some data, select. Then you say the names of the columns where the data is stored. Let's say that you want to select the first name in a table that has information about the person. Select first name from, then you have to put the name of the table. The table, let's say, is people, right? Select first name from people where, and then you say what conditions. Where date of birth is greater than this, that first letter is J, and so on. And that will retrieve you a subset of that table that contains the data that you ask for. So select from where. Those are is the basic SQL format. Of course, then you have joins, and you have group by, order by, you have window functions, you have a lot of other things that make it even more powerful. But to start with is English. It's just a subset of English. You cannot say choose, you have to say select. Right? That removes the ambiguity. You cannot say connect, you have to say join. So that is kind of the goal there. People thought, well, we finally made it. We made a subset of English that is easy enough for anybody to communicate with a database, to extract data, to store data, to update data, and so on. And everybody said, well, that's it. Now we can teach SQL in elementary school, and children will know how to deal with data, right? Whatever it is. And the whole world is running on SQL. It's probably, the most ubiquitous type of language in the world. But then we decided that even that was too hard for us. And when we created the LLMs, we decided that we didn't like the lack of ambiguity. We really like ambiguity, and we want things to be ambiguous, and we want to communicate with a computer in an ambiguous way and have the computer reduce that ambiguity and turn it into ones and zeros eventually. Which is a bad move, because it was good. It was a good idea for having people develop that ability, right? Everybody should know how to write SQL. It's not that hard, and it forces you to think in a certain way that if you never did, you're missing something. And now we're trying to. So my experience with LLMs has been trying to teach them to create SQL, to extract data. And I couldn't because they couldn't understand. I would give the instructions in plain English, in ambiguous English, not because I'm ambiguous, because that's how English works. And my ambiguity, my intentions would never fully match by the LLM. So it would make up tables, it would change things that were not supposed to change, it would mess up things. And obviously once it tried to run those queries, most of the time they wouldn't work. But that's not the worst part. Sometimes they would work, but are not retrieving what I wanted to retrieve, right? So they made some lucky wrong queries that they would run and they would retrieve data, but it's not what I intended, because again, I'm trying to communicate using ambiguity. So I think that's kind of one of the main issues I have with LLMs is why do we take a step back? We made progress. We had people learning. We were finally figuring out how to communicate. Even it is the computers are as stupid as they always were. It's zeros and one, and they will do whatever you tell them to do. Right? LLMs are just on top of that. They're really that stupid. Like I said, they're not intelligent. They just figure out language, but there's no intelligence, there's no consciousness, there's no intention. There's nothing, right? There's just statistical models. But as a humanity, we're losing, that ability that we were developing. Now, this is and I think I will close with this thought, but this is a problem, the real problem. Let's put it this way. I know people who are building these kind of tools using LLMs that basically are replacing SQL. Instead of teaching people how to write SQL or modify SQL templates, they decided, no, people are too stupid. We need to give an LLM that will do that for them. So now we have people using English telling the LLM what they want. The LLM will write the query, will run the query, and will give them the results. Right? The person who asked for it has no idea if that is correct or not. Even if the LLM tells them, well, this is the query I ran, they have no way to verify that. So basically, you don't know what you're getting. There's always uncertainty. And even if it works 99% of the time, well, there's 1% that mess things up, and nobody would know. But when they figure out that it's wrong, because it's too wrong, the instruction that we give the user is, oh, you need to give more context. Basically, the way we're trying to reduce ambiguity is by adding more and more information. So you have to describe why are you asking this, what is your project, what are you trying to do, what do you expect to see, and a lot of context. So the LLM will capture that context and hopefully will understand, even though they can't understand, but it will build something that most likely or closely, relate you to what you're trying to get. And this is the dumb thing. An analyst, somebody who understands the data, the databases, and everything, could probably write a query that, let's say, would take 20 words. For a fairly, I don't know, not the simplest, but not the most complex of queries. So 20 words. You need 20 words to write a SQL query that would answer the question that these people are asking. But instead of that, an analyst is relatively cheap, salary-wise. But now we have, let's say, an executive whose time is very, very expensive, speaking for hours to an LLM, giving them hundreds, thousands, tens of thousands of words that they will be processed in data centers all over the world, using satellites, using fiber optics, using water, using energy, to give enough context to try to constrain the 20 words query that an analyst could figure out in probably 10 seconds. Instead, we have hours of very expensive executive trying to have the thing, giving them the answer that they want. And when they get it, they don't know if it's right. And sometimes they even call an analyst, say, hey, is this correct? Think about the waste of time, the waste of money, the waste of energy, the waste of water, but the waste of intelligence. Because we are not getting new analysts down the pipeline. Nobody is learning SQL. Why would you? when you're told every time that, you know, a machine can write better SQL than you could ever do, and 1,000 times faster than you could. Yeah, the writing part could happen 1,000 times faster. The getting to the point in which writes something that is better than what the human, definitely not. I really hope that people will start seeing through all these lies, all this hype. I kind of lost faith. Tomorrow is SpaceX IPO, and I think that will tell a lot about, you know, where we are as a species. Have we been dumped enough that we will still be giving our money to billionaires, to almost trillionaires, based on fiction, based on lies, based on smoke, hype, snake oil, call it whatever you want. I will leave this for other videos probably. I don't want to make it this much longer, but I hope it helps somebody think about these things. We were getting somewhere. We were learning how to communicate, how to think algorithmically, how to think in steps. This leads to this. If this doesn't happen, this will not happen. All that is being lost as we speak. Maybe you're not interested in computers. Maybe you're interested in computer language. I would say that you should still learn it because it's a way of thinking. It's the same thing with mathematics. Mathematics is not ambiguous. It's a way of thinking. It's a way to understand the universe. It doesn't care about opinions. It's not about beliefs. It's not about feelings. It's about reason. It's about intelligence. It's about choosing. Is about solving problems, and that's what I feel we are missing at a very accelerated speed. So, well, I will keep it this long. This won't be edited. I'm in vacation. I don't have anything to edit this with, but I hope you still enjoy it without the intro and outro. Well, see you in the next one. Bye bye.